Lesson 2.6, Properties of Equality and Congruence. This is a introductory to proofs. How do we prove something? We write down reasons for what we do, and we call that a proof. And hopefully our reasons are based on things that have been established in the past to be true, instead of reasons that we think or wish would be true. So some of these reasons that we would use would be things like the reflexive property, which is incredibly silly sounding. It just means that something is either congruent to itself, if we're talking about geometry, or it equals itself if we're talking about algebra. And algebra talks about numbers being equal. Geometry talks about things being congruent. So two more of the properties are symmetric. If, and I like to just call it A and B. If A is equal to B, then B is equal to A. It just means if, X equals Y, Y equals X. And same thing over here. Shapes, segments congruent to another segment, then that segment is congruent. And these are very basic and simple sounding. And transitive, we finally get a little bit more complex. If A is equal to B and B is equal to C, then A is equal to C. We just did something like this very recently with logic. We're trying to tie the two together. And it's the same thing over here. If segment AB is congruent to CD and CD is congruent to EF, then AB is congruent to EF. So it's transitive property. Now we can use this to do proofs. Write it in as reasons. It's very confusing because people don't naturally take to proofs. They have to be led to them. So for example, N's the midpoint and P's the midpoint of these different chunks. We can prove that MN, this chunk, is equal to this chunk. And remember, that means the distance between M and M. Well, the first two are just midpoint definitions. This is the same thing. This is very challenging for people to see, but I do it again. If A is equal to B, and B is equal to C, then A is equal to C. And that's just, very simply put, transitive property. Now, most people will write transitive property of equality or transitive property of congruence. I don't really get into that. Transitive property is good enough for me. Check with your teacher. They might be a little more detail-oriented. So, here's a proof. Most proofs will have statements on this side. Proofs I'm doing in this class, you just write them out, we assume. And then the reasons on this side. This was given to us, so the first reason is just given. And that just means here's the problem, go to it. First step, we don't have to come up with it, it's just given to us. So we are going to add 3 to both sides. And the reason we can do that is the addition property. So that gives us 7x equals 28. That's still part of step 2. And let's put that in the right color so it's not as confusing. Then say, oh, we got 7x 28. Let's divide by 7. So that'd be the division property. And we're left with x equals 4. We don't need to write down a reason. That's just actually, just like before, that's part of the previous step. So why did I do that? Because you've been doing proofs in algebra, but you didn't realize it. You're justifying each step with a reason. Oh, that's addition property, that's symmetric property, that's division property. So this is not really new, but it just looks very different. And why do we write it all down as a proof anyway? Why? Well, this way I can follow what you did. In case you just say, oh, it works. Well, prove it to me. Okay, I'll write out my steps. Okay, now I follow what you did. That makes sense. Or I can find mistakes. Do a proof. I say, that's not right. Show me. You write out your steps. Oh, look at step 6 here. You made a small mistake. So here's a proof. And again, it should have this whole statements and reasons. We're not going to do that in this class. And we're saying if M is the midpoint, show that the whole thing is double that. And this is kind of what I call a duh proof. It's pretty obvious. So if it's the midpoint, then the two pieces are equal. Midpoint. And if we take this whole piece and break it up into segments, that's called segment addition postulate. Something we talked very briefly about in the past. Then we say, well, MB is equal to AM. I'm going to take it. AM is equal to MB. I'm going to take it and plug it in there. So that's substitution. We substituted it in. And again, we have property of equality. I never write the of equality. I just keep my life moving. And then we just sum them up. And that's actually the opposite of the distributive property, but we call it distributive property. If you're not confused, you should be. This is tricky stuff. And we're just giving you a taste of where it would go, because geometry is very proof-based. It's one of the brilliant things about it is that it's been proven, so it's been used for years, and it works every time because somebody sat down and proved it all. Do you need to worry about that? Not in my class, but you might in another class. So this is just an introduction. If you're confused, that's fine. We'll build you up from here. That's it. Good luck.